We have here a second order differential equation. This one could be thought of as a mass spring system, but we don't need to think of it for this technique. But we have the second order differential equation here, and what we want is we want a system of two first order differential equations. What that looks like is we want some y prime equals, and then we'll introduce another variable v and have a v prime equals. And we want this system to be equivalent to this second order original differential equation that we're given. This is one approach that people take for higher order differential equations, is to turn them into systems and then to work on the systems, and we want to see how to do that. So what we're going to do is we're going to define v to be the derivative of y. You can think of it as velocity. If y is a position, then the derivative of the position is the velocity. So we're going to define v in this way. It's like a new dependent variable for us. Then that would mean that y double prime would be v prime. And if I take the derivative of this equation, I get y double prime equals v prime. We also know something else about y double prime. We know what y double prime is from the original differential equation. So we also know that y double prime is equal to 3 times the cosine of 2t minus 2y prime minus 3y divided by 4. If I solve this for y double prime, that is what I get. So we can equate these things. We have y double prime is v prime, but also y double prime is this thing. So we can now write our system of differential equations. Y prime equals v, and y double prime, which is v prime. Remember, that's what we wanted. A y prime equals something and a v prime equals something. That's what a system of first order differential equations looks like. So I have y prime is v, and I have v prime is y double prime, which is this. 3 times the cosine of 2t minus 2 times y prime. What is y prime? In terms of my new variables for the system, y prime is v. And then minus 3y all over 4. This is my system of two first-order differential equations. It's equivalent to this second-order differential equation in the following sense. If I can solve this system of two first-order differential equations, I will have y of t and v of t, and y of t is the solution here. So I will have the solution to this second-order differential equation if I have the solution to this system of two first-order differential equations. What we want, remember when we're trying to do this, is we want two differential equations, both first order. We want our two dependent variables here, so y prime equals and a v prime equals, and then we want everything written in terms of y and v, the new dependent variables. So I did replace the y prime with a v, because everything on the right-hand side should just be y's and v's. There should be no derivatives there anymore. This is our system that we can now work with.